of or explosive welding. Here, in the previous cases, like resistance welding and arc welding, we have studied about how the different methods of heat input can be used for welding purpose. But in this today's class, we are going to study the heat and input by means of explosion or explosives. So therefore, that we are going to learn now. Here, you can see this diagram first. Look at this diagram carefully. So in this diagram, you can observe an anvil block. This is the anvil block, which is the basic material or base support. Above this, the metal part, that is base plate, is kept. Above the base plate, we have kept the welding material, or it is also called as flyer plate. Flyer plate, it is also called as cladding material. Cladding material. Okay. And above the flyer plate, this is the flyer plate or cladding material. Above this, you can see the red colored one. It is the explosive. Explosive packed throughout the length of the material. That is the cladding material. So this cladding material, a gap is maintained. A gap is maintained. So sufficient gap so that to attain the required amount of kinetic energy. So this gap is maintained. Now what is happening? This distance is called as standoff distance. This distance we call it as standoff distance. So now what? The back side towards the left side, you can see the material flyer plate or the cladding material is cladded to the base material or base plate. But towards the right, you can see where the explosive is there. In that region, you can see still there is a gap. Gap means that is the air gap is there. So that is the standoff distance. The flyer plate, the material to be cladded is placed at a distance that is called as the standoff distance. So now what is happening here? We are igniting or initiating the explosion. This the explosive is placed on this plate, so that as soon this explosive is ignited, then what happens? See, the explosion takes place. When the explosive is ignited, explosion takes place. Due to that explosion, it releases enormous amount of energy, and that energy acts upon the plate on which it is deposited. See, the plate on which it is deposited means it is the cladding plate or cladding material upon which the explosive is placed. So what happens? The cladding takes place, or the explosion takes place. Due to this severe amount of energy, so this flyer plate travels at a greater speed, greater velocity. So therefore, it hits the Yesterday, we were discussing about the explosive welding. Is it Devendra Reddy's timetable or my timetable? See, we were discussing about the explosive welding. Am I audible now? First, I would like to have the clarification. So, am I audible?
Yes, sir.
Yes, sir.
And screen is also visible. Say fast. Yes,
Yes,
or
sir,
no?
it is visible.
Okay. See, this is the Venkatesh Reddy sir class or my class? According to your timetable? Okay, anyway. Here, I have shown, today we are studying about the explosive welding. This is another type of welding where the energy supplied for welding is by means of explosion or explosive. You can see here the arrangement of this diagram. There is a base plate, or it is called as the anvil. Yes. There is a base material or base plate. It is called as the supporting plate, or it is also called as the anvil, this base one. Above this, there is a metal base plate. So to this base plate, we have to clad nothing but joining or bonding of other type of material. For example, mild steel material is there. Mild steel material. Upon the surface of mild steel material, some copper material, a thin layer of copper material to be cladded. Cladded means gluing type, adhesive type. So we have to paste another type of material. That is, it may be copper, it may be any other type of material. Okay. So two different materials are to be cladded. Okay. So then in that case, this method is available. What is this method? It is called as explosive welding. Here, let us see, there is a base plate, or which is the anvil, which is called as the anvil, and above this anvil, the base material to be welded, it is kept here. That is work holding device. You can see work holding device. It holds the workpiece in proper position without any disturbance, without any dislocation. Dislocation means locating or dislocating the workpiece. That is movement of workpiece from one place to another place by vibration. It should not happen. That is why holding device. This work holding device holds the workpiece properly or firmly. So this is the base metal to be welded. Next, what is here? A flyer plate is placed at the end. You can see flyer plate. What is the meaning of flyer plate? This flyer plate to be bonded to the base plate. This, so this is a thin material. This to be bonded to the base plate or welded. Bonded nothing but welded. So this flyer plate to be welded to the base plate. For that purpose, what we are doing now, Here, above this flare plate is arranged like this at some angle theta. At some angle theta, it is arranged like this, placed like this initially. Next, what we are doing, above this flare plate, there is a line of explosion or explosive, you can see. So there is a buffer plate. Buffer plate means it should not cause any damage to the flare plate. So there is an explosive. That explosive, during explosion, it should not cause any damage to the flare plate or the plate to be welded. For that purpose, there is a buffer thickness of some material. Okay. Above this buffer, you can see the explosive. Okay, detonator. It is also called as the detonator or explosive. It is placed along the length of the workpiece or length of the flare plate. So this is the basic arrangement, initial arrangement of the workpieces to be welded. Next, what we are doing, there is a ignition. There is a tape for ignition, magnetic. There is no manganese tape. You can see here. When it is ignited, so then this explosive starts bombarding. Explosive start bombarding or start releasing the energy. Okay, explosion nothing but what happens? Chemical reaction takes place, because of that energy is released. That is the purpose of explosion. So therefore here, as soon the ignition starts or ignition, this explosive, immediately it start releasing the energy due to reaction. So that reaction energy is acting upon the flare plate. So therefore, due to that explosive energy, the flare plate flies nothing but travels with a great kinetic energy in the downward direction, and it come and hit the base plate. This flare plate at great velocity come and hit the base plate. So that what happens, the cladding of the flare plate takes place with the base plate. It is just cladding. Cladding means interlocking of the bonding. Okay, interlocking of the atoms. How exactly it takes place means by means of this supply of high velocity or high kinetic energy due to explosion. Okay, due to explosion, which is explosive material is loaded or it is placed on the surface of the flare plate. Okay, this is a simple concept of explosive welding. Normally, where it is applied means, for example, this material, this is the corrosive material, which one? Base plate. So outside a costly material to be cladded, So then, for cladding purpose, cladding means just take adhesive. Okay, that is a gluing type. So bonding. So for that bonding purpose, we are using another material which is expensive material, which is non-corrosive material. So in that case, what we are doing, we are making the flare plate to be inclined at some angle, and a detonator is arranged above that, a line of detonator, and it is ignited. So as soon as it is ignited, it releases enormous amount of kinetic energy. Due to that, as a reaction, that kinetic energy is imparted to the flare plate. Therefore, flare plate fly. Flyer, why it is called flyer means it is flying from initial position to the final destination on the base plate. It lands on the base plate with great velocity. So therefore, locking of that or bonding of that flare plate and base plate takes place. This type of welding is called as explosive welding. You can see here explosive force generated by ignition of explosive material will travel at very high velocity. Okay. These forces are used to cause ripples in the base plate and lock them together. Okay. The base metal parts are placed at an angle to each other, theta, at an angle theta to each other. The parts are covered with flexible rubber, and it explosive material is covered, so that it should buffer is there. So this has to be covered with this buffer material, so that it is not causing any deterioration destruction to the base material. For that purpose, a protective layer is provided. Okay, a detonator is used to detonate the explosive material. Okay, the force of detonation results in ripples in the parts, and shock waves will lock the parts together. What makes it to lock means it is due to the shock waves. What is the meaning of shock waves? Sudden shock, nothing but sudden. Okay, say high intensity sudden waves, shock waves are responsible for making the locking of the two parts. Okay, like and unlike metals can be joined. This is the very important character of this. So it can be for joining of dissimilar metals. Normally, metal inert gas welding and tungsten inert gas welding, whichever may be the type of welding, so they are used for welding the similar metals. But here, this can be used for welding dissimilar metals. It means that I told you already, dissimilar. What is the meaning? The base metal is made of one type of material, mild steel or cast iron or some other material, and flyer plate, it is the thin section, thin material is taken. So just to coat on the surface. So a thin material is used, like a copper, it may be expensive material. So that can be coated on the, that can be added or cladded on the surface of this base material. So therefore, chemical composition of the flyer plate is different, chemical composition of the base plate is different. So therefore, dissimilar metals can be joined by this method. Okay, this is about the explosive welding. So different types of explosives are used for that purpose. Okay, this is the basic, just basic concept of explosive welding. So one type of welding, it is possible to do the welding by means of explosion. Okay. Any question on? Basic concept, it is very simple concept, but what type of detonator is to be used, what angle is to be used, all these things need to be designed in a proper way, because theta, depending upon the thickness of the material, how much kinetic velocity, kinetic energy is to be imparted, and what is the thickness of the detonator, what type of detonator, those things, complete design, it is different. Here you are not designing here, just we are learning at this stage what is the meaning of the explosive welding. So therefore, basic concept is just kind of high velocity or high kinetic energy is imparted to the flyer plate by means of explosion, or by means of detonating the explosion, so that the kinetic energy, the shock wave, high intensity shock waves, make it to lock both the plates together. That is the basic of explosive welding. Any questions are there on this? You can ask now. Any questions on this? You can ask. Parmeshwar Aradhya. Since how long you are waiting in the lobby? Akashar? Himamant Vaisi?
Sir.
Okay. Any doubts?
No, sir.
Jivan S. Jivan S. Whoever is not responding, just I will remove from the class now. Jivan S. KG Satish. Lavya. Muhammad Adnan.
Yes, sir. No doubt, sir.
Lavya. Dikash. Nishant Kumar Jha.
Yes, sir.
Parameshwar Parameshwar Aradhya, Puneet Kumar S, Sandeep M, Sayed.
Yes, sir.
Sayed. Okay. Vignesh
Yes, sir.
NG. Vignesh.
Yes, sir.
I think Puneet Kumar S is not there. Parameshwar
Present,
Aradhya.
no doubt, sir.
Who? Allah, Puneet Kumar S is not there. Parameshwar Aradhya. Nishant Kumar Jha.
Yes, sir.
Okay. Akash R ಇವನು ಇಲ್ಲ.
Sir.
Puneet Kumar S. Puneet Kumar S. Okay. This about the explosive welding. Next, let's go to the another type of welding, which is called as the thermit welding. It is a special type of welding, actually special thermit welding. Here, in thermit welding, we are not using electrical energy. We are not using gas for combustion purpose. So nothing, yes, some special type of welding. It is taking place by means of chemical reaction. Okay. So that is called as the thermit welding. That we will study now. Sometimes you might have seen the railway track. Have you seen the railway tracks? How many of you seen? How many of you not seen? Railway track. Have you seen?
Yes,
No,
sir.
no answer means. Akash.
Sir.
Akash or.
Sir.
ಏನಪ್ಪ ನೀವು ಕರೆದ ತಕ್ಷಣ ರೆಸ್ಪಾಂಡ್ ಮಾಡಲ್ಲ. You
Sir,
don't respond when I call.
ಸರ್ ಅದು ಸರ್ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಕ್ಕೆ ಆಪ್ಷನ್
Yes.
ತೋರಿಸಲ್ಲ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಕ್ಕೆ ಆಪ್ಷನ್ ತೋರಿಸಲ್ಲ ಸರ್ ಆಗ್ಲೇ.
Okay. So have you seen the railway track? Have you seen the railway track?
Yes, sir.
So in that railway track, sometimes breakage occurs. Breaking of railway track occurs. Breaking of railway track occurs due to continuous usage of the, and then due to fatigue. Railway, that may happen. So during that time, what happens? The breakage occurs. It has to be joined again. That two parts of the tracks to be joined. Okay, railway track. It becomes after breaking. Then we cannot run a train on that because it is broken, damaged. So therefore, it has to be joined. So much of inconvenience. So when there is a breakage in railway track, we cannot run a train on that broken parts, broken railway track. Why means, so there is going to be catastrophic failure, damage, accident. So therefore, before running that, we have to weld the railway track. So then assume that it is taken place at some remote places, forest area, hilly area, where there is no power supply, electric to weld with arc welding or some other welding process, we need the electric energy. So, but there is no electricity there. Then how to perform welding operation in such areas? Okay. So for that purpose, there is a special type of welding which is called as the thermit welding. This type of welding uses no electric power. It will not use electric power. So it is the combination of casting and welding. This method, thermit welding, it is the combination of casting and metal casting, already has studied, and welding. Why it is the combination means, see, the liquid metal is poured. This is the liquid metal. This is the railway track. For example, section 1 and section 2, or this is one part I section and this is another part, two parts left and right, you can see. If we are to join these two, then liquid metal is to be filled into this. Liquid metal is to be filled into this. For that purpose, what we are doing to fill the liquid metal, where is the liquid metal available? In the forest area, or in a hill, or it is some remote place where there is no power. Liquid metal is also not available. For that purpose, we are using the chemical reaction between two metals or two materials. That chemical reaction releases enormous amount of energy. At that energy, the metal will be melted and that is poured into the gap between the parts. So then it is allowed to solidify, it is allowed to cool, so that both the parts are joined. This is how it is carried out. So now we will try to understand what is actually the thermit welding. Okay. See, in this diagram, first you go through this diagram. Are you able to grasp the thing? Say yes or no, quick. I want some
Yes, sir.
immediately. Okay. See, this is the track, which is the broken track, the center, work I section and work I section, you can see. Okay. This is one part, this is the other part, it is broken. Now, what we have done to join these two parts now, there is a mold cavity. There is a molding sand, everything. Earlier, you remember, you recall your memory from first chapter. So that molding sand, it is placed here. A box is constructed so that we have filled the molding sand around this crack, around this breakage. We have filled this. Then the gap is filled with the wax. The gap between the metal is filled with the wax, and then it is completely packed with the molding sand. There is a provision given for this gap, runner, riser, everything gap is provided. You can see the sprue here, sprue through which the molten metal can be poured. When we are pouring the molten metal, it comes to this part, wax is there, that wax will be melted and then that will be going out. Okay. So now what we are doing, here you can see, this is the basic arrangement, the casting arrangement. That is why it is the combination of casting and welding. Okay. So above this, you can see there is a crucible. There is a crucible. You know, all of you, what is the meaning of crucible? It is a metal melting device, small metal melting facility or pot type pot. which can take the metal. Uh, Crucible is used to transfer the metal or to melt the metal. So now what we are doing, we have taken a crucible. Inside the crucible, the chemical mixture is filled. What is that chemical mixture? That chemical mixture we call it as thermit mixture. That chemical mixture we call it as thermit mixture. So what is the combination of thermit mixture? I will tell you. So this is the thermit mixture which is filled in the container or crucible. This thermit mixture, exothermic compound, exothermic compound. You know, all of you, what is the meaning of exothermic compound? So during reaction, it releases the energy. That is the exothermic. So therefore, that thermit mixture is placed here in powder form. Then there is an igniter, igniting ribbon. So through the igniting ribbon, so it is ignition is initiated. Ignition is initiated. So then reaction takes place within this mixture. Enormous amount of energy is liberated or released. During that time, the metal will be melted. Here, metal particles will be melted and it is converted into liquid. That liquid, molten liquid is, see here, molten liquid is made to flow into the crack surface or where the crack is placed. So into that crack area, the molten liquid metal, it is coming or flowing down. So then it is allowed to cool sufficient long period of time. Then it is taking place between part 1 and part 2. So then the bonding will be taking place. Then after that bonding is over, we are going to remove the moldings and everything. We are going to remove it out. So like this is called as thermit welding, where it is not using any electrical power or any other external energy for the purpose of welding of two parts, broken parts. So now, after having understood about this basic principle with the diagram, now I am going to explain you with the help of this. What is thermit welding? Thermit welding is primarily a fusion welding. Fusion, nothing but solid is converted into liquid metal, liquid again fuses into solid. Okay, so therefore it is converted into liquid, again it is solid. So it is primarily a fusion welding process in which it is affected by pouring superheated liquid. So we are going to pour the superheated liquid metal into the gap. So by means of the welding is accomplished or achieved. The high temperature obtained from, where from we are obtaining? Reaction of finely divided metallic oxide. That is called, we have seen that thermit mixture. What is that thermit mixture contains? It is the finely divided metallic oxide, usually the iron oxide and aluminium. Iron oxide and aluminium combination powder, it is used. That is the thermit mixture. Iron oxide and aluminium. It is employed to raise the temperature of parts to be welded. Okay, to above their fusion point, the liquid metal acts as filler material. Okay, so that is a reaction. That reaction is explained in these two diagrams, in these two equations. Okay. Thermit welding is based on casting and foundry practice, because we have seen that the foundry sand is used, mold box is used. Okay, so that sprue, gating, everything is used. So therefore, it is basically a foundry practice, welding practice. It essentially consists of providing by means of a chemical. That chemical is called as thermit. Why it is called thermit welding means it is a chemical. That chemical we call it as thermit. So that reaction takes place and molten metal is produced due to reaction. What is that reaction? You can see. Already it was told here. Here it is the oxide, metallic oxide, usually iron oxide and aluminium. So that reaction it is shown here. So iron oxide and aluminium reaction takes place and it is going to give rise to Fe aluminum oxide plus heat. This much amount. Okay, KCAL, kilocalories. So when the reaction takes place, it is going to give this combination Fe3O4 combined with Al. It will give iron and aluminum oxide as a byproduct and giving rise to this much amount of exothermic energy. Exothermic, it is going to release the energy. Or one more reaction is also available, that is copper oxide combined with aluminum. Then the reaction takes place between, then it is producing the pure copper and oxide plus this much amount of exothermic energy. 275 kilocalories of heat is produced. So like that, for welding of railway track and other things, first reaction we are going to use. Okay, because obviously it is made up of iron based composite. That is why the chemical affinity of aluminum for oxygen is the basic for thermit process. What happens here in the iron oxide, oxygen is there. This reacts with this aluminum. The chemical affinity of aluminum for oxygen is the basis, okay, for the thermit process. Thermit reaction, exothermic one. Exothermic means it is releasing the energy. That is why it is called as exothermic reaction. So therefore, thermic temperature from reaction 1, it is 7193 kilocalories, or in degree centigrade, it will raise the temperature up to this much temperature due to release of this much amount of heat. Okay, but due to losses, radiation losses, the final temperature it may come out to 2500 degrees centigrade, which is sufficient to melt the iron. The thermit mixture is ignited with the help of special ignition powder consisting of largely barium peroxide. That is the ignition purpose, that compound is used, barium peroxide. Using that, the combination is to be ignited. This in turn ignited by burning magnesium ribbon, etc. Okay, the totally this is the ignition process takes place. Because of the ignition, what is happening? Because of the ignition, the thermit reaction takes place. Due to thermit reaction, there aluminum reacts with oxygen, then aluminum oxide is produced, Al2O3, and iron is produced and energy is released. That is the reaction to be remembered. So then that is all about this process, how exactly. So therefore, now you have understood that what is the meaning of thermit mixture. It is the mixture of iron oxide and the aluminum. So then aluminum reacts with oxygen, aluminum oxide is produced, iron will be separated, that iron will be melted, and then that molten iron will be made to deposit in this gap. Okay, so like that, the joint is made between the broken parts. Okay, so this is the basic concept of thermit welding. Applications. Where do we use this application? Thermit welding, joining of heavy sections, like just now I told, or this is one example, heavy pipe sections. There also we are, if crack is there, okay, there also we are going to use, or new joint is to be made. Not only crack, new joint is to be made. Then also we are going to use the same thing. Okay, welding of pipe joints, thicker pipes will be there. There also we are going to do the same thing. Repair field, maintenance of shafts, machinery, frames, etc. There also this type of welding is done. Then welding of railway tracks or railway rails, so etc. These are all the different applications of thermit welding, where it is not possible to do the conventional type welded, that is traditional type of welding. This type of welding, thermit welding, is being practiced. What are the advantages? The heat necessary for welding is obtained from chemical